Assalamu alaikum. Myself, Dr. Ansari Farzana Meduzama, Assistant Professor in Chemistry, JT Art Science Commerce College, Malad. Today we will discuss about the Physical Chemistry, paper first, CH101 of FYBSc. Welcome all of you. Today we will discuss the second chapter of the FYBSc, Chemical Equilibrium. The second law of thermodynamics gives the condition of spontaneity with the introduction of new function entropy. The criterion for spontaneous process applies only to an isolated system. In order to decide about the feasibility of process, we must know the total entropy change. That means entropy change in a system as well as that of surrounding. Chemists are generally interested in a system which interact with surrounding environment rather than the isolated system. It would be preferable to have a criterion that could be applied to a system itself without having to worry about the change in surrounding. Such a criterion can be developed in a straightforward manner for processes such as phase change and chemical reaction that occur at constant temperature and constant pressure. Hence, a new thermodynamic function, the Gibbs free energy or free energy, is introduced and it is defined as G is equal to H minus Ts. एंट्रोपी क्या है? सेकंड लॉ ऑफ थर्मोडायनेमिक क्या बोलता है? एंट्रोपी ऑफ अ स्पॉन्टेनियस प्रोसेस इज टेंडिंग टू मैक्सिमम और इंक्रीजेस एज टाइम पासेस. तो एंट्रोपी चेंज इज नथिंग बट अनअवेलेबल पार्ट ऑफ एनर्जी, or you can say that it is the measure of disorder or randomness of the system. एंट्रोपी जैसे जैसे वक्त पास होता जाता है एंट्रोपी गोज ऑन इंक्रीजिंग. जैसे हम पहले यंग रहते हैं तो हमारे काम करने की कैपेसिटी अच्छी रहती है. जैसे जैसे वक्त पास होता है हमारे बॉडी में डिसऑर्डर आता है. तो हम दादर चढ़ते हैं तो हमारी सांस फूलती है, ज़्यादा चलते हैं तो पैर दर्द करते हैं, एक्सेट्रा. ऐसी बहुत सारी प्रॉब्लम आती है. मतलब डिसऑर्डर हमारी बॉडी में जो है वो इंक्रीज़ होता है एज टाइम पासेस, एज योर एज गोज ऑन इंक्रीजिंग. जैसे स्टार्ट में नोटबुक जो रहती है वो जो है टाइटली बाइंड रहती है. जैसे जैसे टाइम पास होता है नोटबुक ढीली होती जाती है. इसी बात को आप क्या बोलोगे? एज टाइम पासेस एंट्रोपी गोज ऑन इंक्रीजिंग. स्टार्ट में हमारी व्हीकल 1 लीटर में 100 किलोमीटर चलती थी, लेकिन जैसे जैसे टाइम पास होता है उसके पार्ट्स जो है वो ख़राब होना शुरू होते हैं. आप बोलोगे उसके एंट्रोपी गोज ऑन इंक्रीजिंग. तो 1 लीटर में वो 80 किलोमीटर चलती है. इस तरह से अपने सराउंडिंग में हम जब देखेंगे तो हमें ऑटोमेटिकली ये नज़र आता है कि इन ऑल स्पॉन्टेनियस प्रोसेस एंट्रोपी गोज ऑन इंक्रीजिंग. अब केमिकल इक्विलिब्रियम समझने के लिए एक न्यू थर्मोडायनेमिक फंक्शन इंट्रोड्यूस हुआ, उसे कहते हैं गिब्स एनर्जी. गिब्स इंट्रोड्यूस दी free energy, hence it is called as Gibbs energy. Helmholtz also introduced the free energy and it is called as Helmholtz free energy. Free energy is nothing but the available part of energy. Unavailable part of energy is called as entropy, whereas available part of the energy goes on डिक्रीजिंग एज टाइम पासेस. जैसे अभी एक व्हीकल की एग्जांपल हमने लिया कि जैसे जैसे वक्त गुजरता है जो व्हीकल रहता है हमारी स्कूटर जो रहती है उसके पार्ट्स जो है वो जो है लूज़ होना शुरू होते हैं, जंग उसमें आना शुरू हो जाता है या कुछ भी ख़राबी पैदा होना शुरू होती है. तो जैसे ही हम स्टार्ट में क्या होता है एकदम नई रहती है जब तो स्कूटर जैसे ही स्टार्ट करते हैं तो पीछे से फ्यूम निकलता है। वो फ्यूम क्या है? अनअवेलेबल पार्ट ऑफ पेट्रोल टू ट्रांसफ़र द व्हीकल फ्रॉम वन स्टेट टू अनदर स्टेट। तो स्टार्ट में वो फ्यूम की क्वांटिटी कम रहती है क्योंकि ऑल पार्ट्स आर न्यू और टाइटली ऑर्गेनाइज्ड इन अ वेल ऑर्गेनाइज्ड फैशन। लेकिन जैसे जैसे टाइम पास होता है पार्ट्स लूज होते जाते हैं और क्या होता है, जैसे ही हम गाड़ी स्टार्ट करते हैं तो धुएं की क्वांटिटी बढ़ जाती है, मतलब एंट्रोपी जो है वो बढ़ जाती है, अनअवेलेबल पार्ट ऑफ एनर्जी बढ़ जाती है, लेकिन अवेलेबल पार्ट ऑफ एनर्जी जो रहती है वो कम हो जाती है। तो अवेलेबल पार्ट ऑफ एनर्जी इज कॉल्ड एज फ्री एनर्जी, एंड फ्री एनर्जी may be defined as G is equal to H minus Ts. H stands enthalpy, whereas T is the temperature of the system. Since Gibbs function is defined slowly in terms of state function, Gibbs function is the entropy is a state function, as well as free energy is also a state function. That means it depends upon the initial state and final state. Throughout chemistry, we use only change in Gibbs free energy of system for a process occurring at constant temperature and pressure. The change in Gibbs free energy is delta G is equal to delta H minus T delta S. At constant temperature, change in free energy is the difference between change in enthalpy and change in entropy. Hence, the criterion for spontaneity of a process is delta G is less than 0. मतलब हर स्पॉन्टेनियस प्रोसेस में काम करने अवेलेबल पार्ट ऑफ एनर्जी जैसे जैसे वक्त गुजरता जाता है, अवेलेबल पार्ट ऑफ एनर्जी गोज ऑन डिक्रीजिंग बट अनअवेलेबल पार्ट ऑफ एनर्जी गोज ऑन इंक्रीजिंग। तो सेकंड लॉ ऑफ थर्मोडायनेमिक्स क्या बोलता है? डेल्टा एस इज ग्रेटर दैन 0 whereas the delta G is less than 0। हम जब यंग रहते हैं तो हमारे काम करने की कैपेसिटी ज़्यादा रहती है। तो जैसे जैसे हमारी एज पास होते जाती है हमारे काम करने की कैपेसिटी कम होते जाती है, फ्री एनर्जी गोज ऑन डिक्रीजिंग। या gives free energy change in a chemical reaction. The thermodynamic function used as a criterion for spontaneity of a chemical reaction is the Gibbs free energy of reaction, delta G, which is commonly referred to as reaction free energy. This quantity is defined as the difference in molar Gibbs free energy of the product and reactant. Delta G for the chemical reaction is nothing but equal to the total energy. Consider, you will be better understood with the help of a simple reversible reaction. Consider a reversible reaction. A moles of A reacts with B moles of B, gives us C moles of C and D moles of D. It is a chemical reaction. So free energy for this chemical reaction can be written as delta G is equal to sum of free energy of product minus sum of free energy of the reactant. The standard Gibbs free energy of the reaction delta G prefix 0. Delta G prefix 0, it is called as delta G standard, is defined like the Gibbs free energy of reaction but in terms of standard molar Gibbs free energy of the reactant and product, such as delta G 0. Delta G standard is equal to sum of NP G standard of the product minus the sum of NR G standard of the reactant. NP and NR are the number of moles of product and number of moles of reactant. So standard free energy is also the sum of standard free energy of the product minus sum of standard free energy of the reaction. That is, the standard Gibbs free energy of reaction is the difference in Gibbs free energy between the product in their standard state and the pure reactant in their state at 1 bar pressure at a specified temperature. The most stable form of an element is the lowest is the state with a lowest Gibbs free energy. Alternatively, the standard Gibbs free energy of reaction delta G 0 in is the change in free energy that will occur if the reactant in their standard state are converted to the product in their standard state. It is fixed quantity for a given reaction and does not vary as the reaction proceeds. So, the above equation can also be written as delta G standard is equal to sum of the change in standard free energy of the product minus sum of change in standard free energy of the reactor. Delta GF standard minus delta GF standard. Delta GF standard gives energy of the formation is the change in free energy that accompanies the formation of 1 mole of that substance from its constituent element when the substance and the element are in their standard state. The standard free energy of the formation of an element in its standard state is 0. The value of delta G standard tell us nothing about the rate of a reaction, only its eventual equilibrium position. There are several ways to calculate delta G standard. On one straightforward way is the combined standard enthalpy and entropy data from table using the equation delta G standard F is equal to delta HF minus T delta S standard F. That means which applies to the reaction carried out the constant temperature. Now, exergonic and endergonic equation or reaction that have a negative delta G standard where energy is released are called as exergonic reaction. When delta G is negative, that means some amount of the energy is released or liberated, and that type of the reaction when delta G standard is negative is called as exergonic reaction. For example, reaction for formation of water from its element is a exergonic reaction. Reaction for formation of carbon dioxide from its element. These compounds are the thermodynamically stable with respect to their element. The reaction that have a positive delta G 0 where energy is absorbed are called as endergonic reaction, where when delta G or standard change in free energy is positive, at that time we can say that certain amount of the energy is absorbed, and that type of the reaction is called as endergonic reaction. For example, formation of diamond from graphite, that means delta G standard for the formation of the compound from its element is positive. This means that these compounds are thermodynamically unstable with respect to its element. These compounds cannot be formed directly from its element. These compounds must be synthesized by alternate route. Now consider the chemical equilibrium. In doing stoichiometric calculation, we assume that reaction proceeds to completion, that is, until one of the reactant exhausts. It is observed that most of the reaction proceed to completion at a specified condition of temperature and pressure. For such reaction, it can be assumed that the reactant are quantitatively converted to the product and that the amount of limiting reactant that remains is negligible. On the other hand, there are many chemical reactions that stop much before completion. An example is the dimerization of nitrogen dioxide, NO2 plus NO2. It gives us N2O4. The reactant NO2 is a dark brown gas and the product N2O4 is a colorless gas. When NO2 is placed in an evacuated sealed glass vessel, it is found that the initial dark brown color decreases in intensity as it is converted to colorless N2O4. However, even over a long period of time, the content of the glass vessel do not become colorless. Instead, the intensity of the brown color eventually becomes constant, which means that concentration of NO2 is no longer changing. This means that the reaction has not gone to completion. It has attained equilibrium. It has attained chemical equilibrium. It is this stage where the concentration of all reactants and products remains constant with time, since there is no change in the concentration of reactant or product in a reaction system at equilibrium. It may appear that reaction has stopped. However, this is not the case. On the molecular level, there is some activity. Reaction takes place in both the direction. The rate of forward reaction becomes equal to rate of backward reaction. Hence, chemical equilibrium is not static but is dynamic. Thank you for watching.